MCP browser agents are not magic clickers. In this video, we will build the beginner mental model first: what MCP is, what a browser MCP server does, what a snapshot is, and why browser agents can fail even when the model is smart. Then we will walk through one small recipe finder example with snapshots, iframe pop-ups, and a file system boundary. MCP is a protocol that lets an AI host connect to external capabilities. For a browser agent, the host sends a goal and instructions, the browser tool opens or inspects a page, a snapshot describes the page structure, the model chooses the next action, and the host executes the click, type, or navigate request. If the task needs an output file, a separate file system tool writes the result. A snapshot is not just a screenshot. It is structured page evidence, headings, links, dialogues, buttons, frames, and element references. That evidence matters because the model chooses actions from what it can see in the snapshot plus the task instructions. Imagine a recipe finder agent. The task is, find one plausible banoffee pie recipe and save a short markdown summary. The agent opens a recipe page. A privacy pop-up appears. If the agent guesses a selector-like button has text agree, that guessed click may fail. The failure does not prove the button is missing. Often the page is more complicated than the guessed selector. The pop-up might live inside an iframe, or the visible text might not map cleanly to the top-level page. So the next useful move is not more guessing. It is, inspect the page. Now the snapshot gives the missing facts. It can show a privacy dialog, an active iframe, and a real button with a specific reference, like button agree, ref F2E26. Now the model has enough evidence to request the correct action by reference instead of inventing another selector. The model still needs operating policy. A better prompt says, prefer snapshots before clicking, prefer snapshot references over guest selectors, handle cookie or privacy pop-ups, skip hostile sites, and write useful partial output early if turn budget is limited. The prompt is not trivia. It is the agent's operating policy. Even after the browser succeeds, the full task can still fail. The browser MCP server may create page artifacts in one folder, while the file system MCP server is only allowed to read and write a narrower folder. That means browsing worked, but file access failed because the runtime boundaries did not match. The boilerplate is connecting MCP servers and calling the agent runner. The developer-owned core is choosing a browser that works in the environment, aligning file system scope with the real workflow, writing instructions that conserve turn budget, and deciding when to skip a difficult site. MCP gives the connection. The developer still owns the operating boundaries. Browser agents are evidence-driven systems. They inspect page structure, follow prompt policy, request tool actions, and depend on developer-owned runtime choices. When a browser agent fails, ask, did it have the right snapshot, the right instructions, and the right tool boundaries?